Welcome to my video on proofs with parallel lines, part 2. Proofs with parallel lines, part 2. Let's do some examples. We have a diagram, and in this diagram we're given that A is parallel to B, and we have to prove that 1 is supplementary to 3. So we have this diagram, we're going to use these angles. So if A is parallel to B, that's number 1. That's the given. Okay. And we want supplementary, so that means if 1 is supplementary to 3, we want a pair of supplementary angles. So the supplementary angles that we have here are angle 2 and angle 3 are a linear pair. And that's the definition of a linear pair. And as a result, if they're a linear pair, then that means that angle 2 is supplementary to angle 3 because we have a straight angle. And as a result, we have angle 2 plus angle 3 is 180. And that's definition of supplementary angles. Two angles are supplementary, then they add up to 180. And as a result, we have, because of the parallel lines, we have angle 1 is equal to angle 2. And that's the parallel line theorem, and angle 1 and angle 2 are corresponding angles are equal. Number 6, if angle 1 is equal to angle 2, that means we want 1 and 3, so we replace 2 with 1. So angle 2 becomes angle 1 plus angle 3 is 180. And that's substitution. And hence, we got 1 and 3 add up to 180. That means that 1 is supplementary to angle 3, definition of supplementary angles. You cannot sub into a supplementary statement like 2 is supplementary to 3. You can only sub into an equation. B, if a line is perpendicular to one of 2 parallel lines, then it's perpendicular to the other line. So we have a line is perpendicular to one of 2 parallel lines. So we have 2 lines. Let's label them A and B. And the lines are parallel, so we're given that A is parallel to B. So if a line is perpendicular to one of them, so let's say the transverse of T is perpendicular to A. So if T is perpendicular to A, which is one of the parallel lines, so we're going to prove that T is perpendicular to the other one, B. Okay, let's see what we have here. We have the given. So we have number 1, A is parallel to B, given. And number 2, as a result of the given, we have, let's call this angle 1 and angle 2. That means that angle 1 is equal to angle 2, PLT, and that we have corresponding angles equal. So what we need now is to have a right angle here. So this is 1 is equal to 2, and so if 1 is a right angle, we to show that 2 is a right angle. So number 3, we have T is perpendicular to A, given. Number 4, if that's perpendicular, so angle 1 is a right angle. Angle 1 is a right angle. That's definition of perpendicular lines. Perpendicular lines form right angles. That means that angle 1 is equal to 90 degrees. Definition of a right angle. If you have a right angle, is 90 degrees. Now we know that 1 equals 2, so that means that if 1 is 90 and 1 equals 2, that means angle 2 is equal to 90 by the transitive property of equality. And hence, we have angle 2 is a right angle. Definition of a right angle. And as a result, because we have a right angle, that means T is perpendicular to B. Definition of perpendicular lines. So I had to go and get the 2 angles equal because of the parallel lines and work with the 90-degree angle to show the right angles. Okay. C, we have a diagram, and in this diagram we have AB is parallel to CD, AD is parallel to BF, 5 equals 3, we got to prove that 2 equals 4. So the parallel lines, what do we say? If we have parallel lines, we're going to have one of 4 properties. We're going to have corresponding angles equal, alternate interior angles equal, alternate exterior angles equal, and same side interior angles are supplementary. So how are we going to get 2 equals 4? Well, we have parallel lines, so if AB is parallel to CD, let's see, we have AB parallel to CD, and that's a given. And as a result of that given, if they're parallel, that means that angle 4 is equal to angle 3. Parallel lines, that's called a PLT, and these are alternate interiors. This is the transversal, and this is across the transversal, so that's alternate interior angles equal. And number 3, I have another pair of parallel lines that AD is, let's see, AD is right here, BF is here, so we have 2 equals 5. So we have AD parallel to BF given. So that means that angle 2 is equal to angle 5. We parallel lines, that's the PLT, and 2 and 5 are corresponding angles. Corresponding angles equal. Now, how are we going to get to 2 and 4? Well, we're told that 5 equals, angle 5 is equal to angle 3. That's in our given right here. And number 6, that if 2 equals 5 and 5 equals 3, that means, and 4 equals 3, so put all them together, and we got angle 2 equals angle 4. And that's the transitive property. But not only transitive property, probably a couple of times. Again, 4 is equal to 3, 3 is equal to 5, so that means 4 is equal to 5, so 2 is equal to 4 in the end. So 5 equals 3, that means 2 equals 3, so we get transitive property twice. Okay. D. The sum of the interior angles of a triangle is 180. The sum of the interior angles of a triangle is 180. So we have a triangle. And we'll name the angles with numbers. The sum of the interior angles. So we're given a triangle, and so we're given A, B, C. We're given triangle A, B, C. And we named the angles, so we're going to prove that angle 1 plus angle 2 plus angle 3 equals 180 degrees. And to do this one, we could do it. What I'm going to do, I have to do a construction. I'm going to draw a line through A, parallel to BC. So that's the first thing I'm going to do, is and draw a line AF. So AF is parallel to BC. There's only one line that will go through A that's parallel to BC. And in math, we can say that's a construction. So, as a result of that, I'm going to label this angle as a 4 and that angle as a 5. So now I have it all ready. So because they're parallel, that means that angle 2 is equal to angle 4, and angle 5 is equal to angle 3. And what we have, and that's number 2, that's the PLT. And these are alternate interior angles equal. This angle is equal to this one, and this angle is equal to this one. So they're alternate interior angles are equal. So now I have to get into here. So how do I get 180 in the triangle? Well, the angle, let's call this one, we can call this angle is BA, that's an F. Let's call this a T so we can get this angle. So we have the that angle 4 plus angle BAF is equal to 180 degrees because we have a straight angle. Now we could do a linear pair on that if we want, but we know they're 180 because it's a straight angle. And we also know that angle 1 plus angle 5 is equal to BAF because of the angle addition property. So if you sub that into here, that means angle 4 plus angle 1 plus angle 5 is 180 because of the substitution property. So we're taking BAF, which is right here. There's BAF. We're taking the BAF, which is 1 plus 5, and subbing it in right here. So that's angle 1, angle 4 plus angle 1, angle 1 and angle 5, which is right here. I'm subbing it in right there. There it is. And that's substitution. So number 6, we have 2 is equal to 4, so angle 2. Angle 5 is equal to angle 3. So we're doing a substitution. So because this is a straight angle which adds up to 180, and because these are equal because of the alternate interior angles, 4 is replaced with 2, 5 is replaced with 3, and we proved that the sum of the interior angles of the triangle is 180 degrees. Let's do some more. There we go. We have a diagram. We're given that AB is parallel to VT, so AB is parallel to VT, and VB bisects the angle, VB bisects the angle ABT. So if that bisects this angle, that means that that angle is equal to that one because of bisector. So now we have to prove that 2 equals 3. So let's see. Here we go. Let's do a given. AB is parallel to VT. So I have to prove that 2 equals 3. So how do I get 2 equals 3? Well, 2 and 3 are involved in this diagram. So what angle is equal to 3 is also equal to 1, equal to 2, sorry. So angle 1 is equal to angle 2 because of bisector. Angle 1 is equal to angle 3 because of the parallel lines. Therefore, we can have 2 equals 3. So here we go. Parallel lines given. And as a result of those parallel lines, then angle 1 is equal to angle 3. That's the PLT, and they're alternate interior angles. Alternate, better spell, interior angles are equal. And we have a bisector, VB, bisects angle ABT, and that's a given. So because of the bisector, if that bisects angle ABT, that means that angle 1 is equal to angle 2. Definition of angle bisector. And we got 1 equals 3, we got 1 equals 2, so that means that angle 2 is equal to angle 3. They're both 3 and 2 are equal to 1, so that's a transitive property of equality. And if, let's have a look at this one. Remember now, you can pause your video even before I do these and work these out yourself. Don't forget, you can always pause the video and do these proofs before I do them, even though I'm doing examples and doing some practice. In any triangle, let's prove in any triangle, the measure of the exterior angle is equal to the sum of the two interior remote non-adjacent angles. So we have a triangle, and these are the interior angles that I labeled 1, 3, and 4. 2 is the exterior angle, so we're given, the given is in the first part, we're given angle 2 is an exterior angle, and the exterior angle, we're given a triangle, we give the triangle A, B, C, and we have to prove. So this is the exterior angle, this is the adjacent interior angle adjacent to it. These are the two remote interior angles. So we have to prove that the measure of the exterior angle, which is angle 2, is equal to the measure of the two remote interior angles. So angle 2 is equal to 3 plus 4. So we're given that we have a triangle, ABC is a triangle, and we're told that angle 2 is the exterior angle. That's the given. As a result, we have that angle 1 plus angle 3 plus angle 4 is 180. Somehow we have to put, how am I going to get these angles equal? Well, I know that the interior angles of a triangle, so the sum of the interior angles of a triangle equals 180 degrees. So how are we going to get to the exterior angle? Well, we know that angle 1 and angle 2 are a linear pair, and that's the definition of a linear pair. You probably could avoid that step, but you have to check with your teacher that if you had to put that in, you could say angle 1 is supplementary to angle 2 because you have a straight angle, and hence angle 1 plus angle 2 equals 180, and that's the definition of supplementary angles. The angles are supplementary at 180, and as a result, in number 2 and number 5, they're both equal to 180 degrees, so angle 1 plus angle 3 plus angle 4 is equal to angle 1 plus angle 2, and that's the transitive property. Transitive property. And you notice that 1 is in both of them, so that means that angle 3 plus angle 4 is equal to angle 2 by subtraction. Oh, we could say, let's put 7 here and say that angle 1 equals angle 1 and call it reflexive. That's the reflexive property of equality. And now call this 8. That's 8. So now we can, angle 1 equals, that's the angle 1. I got angle 1 equals angle 1, reflexive. Now again, we have to say that if you took off the 1s because they're equal, but to make it official, if we say the reflexive property and then we subtract, that would be perfect. That's the subtraction property, because we take 1 off of each side in number 6. And that's the exterior angle, which is 2, is equal to the sum of the 2 interior remote angles. So I apologize for that, leaving up that reflexive. It's just a little glitch, not a little glitch, but you have to say that. Check with your teacher. Now let's do some practice on these problems using the parallel lines PLT property. Number 1, proof. Practice means pause the video and work these out. So we have A and B are parallel. So if we have parallel lines, what do we have? So I can see that I have these two angles here are going to be equal because of the parallel lines. I have 1 equals 3 given, so I got to prove that 3 is equal to 2. So number 1, A is parallel to B. Number 2, that angle 2 is equal to angle 1. And that's, again, PLT. And these angles are, that's an exterior angles. So that's the alternate exterior angles are going to be equal because the lines are parallel. Number 3, angle 1 equals angle 1 equals angle 3 given. And we got 2 equals 1, 1 equals 3. So angle 2 is equal to angle 3, or 3 is equal to angle 2 by transitive property. Okay, let's do another one. Number 2. Let's see what we have. We have this diagram. What I like to do sometimes, is a lot of times, is actually look at the proof beforehand to see if I can put it together. So let's look at the given in this diagram. TA is parallel to WX. TA, which is this one, is parallel to WX, which is this one. So let's mark them parallel. As a result of the parallel lines, I can have 2 is equal to 5. And I have also, if you think of it, nope, 2 is equal to 5. Because of the parallel lines, I can have 2 is equal to 4 because of alternate interior. And also I can have 5 equals 1 because of the alternate interior. This is a parallel line, then this is the transversal. And we have a parallel lines here, and this is the transversal. So I got these pairs of angles equal. 4 is equal to 5. That means if 4 is equal to 5, we can come up with 1 equals 2. So here we go. Number 1, TA is parallel to WX, and that's a given. As a result, angle 4 equals angle 2, and angle 5 is equal to angle 1. And that's the PLT under alternate interior. Parallel lines, remember the Z? If you form a Z, that's alternate interior. There's the parallel lines, and there's the Z or the Z. So that's alternate interior angles are equal. And we're given that angle 4 is equal to angle 5. And that's a given. So if 4 equals 2 and 5 equals 1, 4 and 5 are equal, it follows that angle 1 is equal to angle 2. And again, you could say transitive property twice, or you just say, ask your teacher, just say, again, 4 is equal to 5. There's 4 equal to 5, so 2 is equal to 1. And that's the transitive property. Okay, let's continue. More proofs. The more you do, the better you become. Here we go. We have a diagram. We're given that C is parallel to D. C is parallel, so C is parallel to D. So if C is parallel to D, I can see that 2 equals 4. We got M parallel to L. M, I'll do this one with 2 strokes. M is parallel to L. And as a result of these 2 parallel lines, I can see I can get 1 equals 4. They're alternate interior, and right here they're corresponding. So if 2 equals 4 and 1 equals 4, then 1 is going to equal 2 by transitive. So here we go. Number 1, C is parallel to D. Again, if you fit the proof together before you start, then you have a plan. That's the given. And as a result of C, that means that angle 2 is equal to angle 4, and that's the PLT, and that's corresponding angles are equal. And we have M is parallel to L. M is parallel to L, and that means that's because of the given. And what follows as a result of these parallel lines, angle 1 is equal to angle 4. And there, as the PLT, alternate interior angles are equal. So we got 2 equals 4 and 1 equals 4, and as a result, both of these angles, 2 and 1, are equal to 4. That means that angle 1 is equal to angle 2 by the transitive property of equality. Transitive property of equality. So again, illustrating the parallel lines. When you're given parallel lines, you will have, again, parallel lines will give you corresponding angles equal, alternate interior angles equal, alternate exterior angles equal, and the same side interior angle supplementary. Keep that in mind every time you're given parallel lines, and that's what this is about. Given parallel lines, which property is going to come out. Number 4, we got A is parallel to B, so there it is. As a result, what do we have? Well, I can see that if A is parallel to B, I can see that these two angles are equal. They're corresponding angles. That's an exterior and that's an interior between the parallel lines. 3 is equal to 4, so I got to prove that 1 is equal to 5. So 1 is equal to 5. So if 3 is equal to 4, I can get 2 is equal to 5 because of the SAT, supplement angles. So 3 is equal to 4, 2 is going to equal to 5. Parallel lines gives me 1 equals to 2. So substitution, okay, so I can see. So here we go. Number 1, A is parallel to B, given. As a result of that, angle 1 is equal to angle 2. That's the PLT, and its corresponding angles equal. That's exterior, that's interior, and that's the parallel lines. Now, we are given that angle 3 is equal to angle 4. So I'll write that given down. So what happens is that angle 3 and angle 4 are a linear pair. And that's the definition of a linear pair. That means that, did I say 3 and 4 are linear pair? What I meant to say was 3 and 2 are a linear pair, and also 4 and 5 are a linear pair. So 2 and 3 are a linear pair, that's a 2. 3 are a linear pair, 4 and 5 are a linear pair. That means that 3 is supplementary to 2, and we have 4 is supplementary to 5 because of a straight angle. That means if these are supplementary, and we have, notice, we have, do we have enough yet? Let's see, we got 1 equals 2, and we have 3 is equal to 4. That means we have 3 is equal to 4, so that means angle 2 is equal to angle 5. 3 is equal to 3, 4, 2, and 5. 3 is equal to 4, 2 and 5. 2 and 5 are equal by supplement angle theorem. Just keep that straight again. I have 3 is equal to 4. I have the linear pair on these. That's a linear pair. And 2 and 3 are a linear pair. 3 and 4 are a linear pair. And they're supplementary because of straight angle. So because 3 is equal to 4, 2 is equal to 5. 2 and 5 are equal by SAT, supplement angle theorem. Supplements of congruent angles are congruent. And because we have 2 equals 5 and 1 equals 2, that means in numbers we have that 1 is equal to 5. And again, I just draw attention, that's in number 2 and in number 6. I'll put the circles around them to show you where it's coming from. So 1 is equal to 5 because 2 equals 5, which is number 6. Number 2, 1 equals 2. 2 are in both. 2 is right here. 2 is here. So 1 is equal to 5. And that's the transitive property of equality. Takes a while to get used to it. But chapter supplementaries. These are supplementaries, and it can get confusing to put the right combination together. You got to be careful. Number 5, we have the definition of an equilateral triangle is a triangle with all sides equal and all angles equal. So if that be the case, let's prove that each angle of an equilateral triangle is 60. So we have a triangle. We have triangle ABC is equilateral. And so we're going to prove that angle 1, angle 2, angle 3 is equal to 60 degrees. So what we're given, triangle ABC is equilateral. That's a given. Number 2. Now, let's see. That means that angle 1 plus angle 2 plus angle 3 is 180 degrees, because the sum of the interior angles of the triangle equals 180. And we know that all the angles are equal. So angle 1 is equal to angle 2 is equal to angle 3, because that's the definition of an equilateral. All the angles are equal. So as a result, we can say that angle 1 and 2 is equal to 1, and 3 is equal to 1. So that's SUBSTITU substitution. Now I'm just dealing with angle 1. So they're all equal. Since they're all equal, number 2 I replace with 1. Number 3 I replace with 1. So we can add these up. 3 angle 1s equals 180 by addition. And angle 1 is equal to 60 degrees. Division. We're dividing each side by 3. And as a result, if angle 1 is 60, that means that angle 2 is 60. That means angle 3 is 60 by the transitive property, because they're all equal. So you proved they're equal because notice you had to come with the statement sum of the angles is 180, and you can see that because they're all equal, you had to divide by 3. Okay, a couple more to do, and we'll finish these proofs. Again, sometimes the proofs can be a little bit tedious, but you can hopefully see and understand how to do the proofs, how you put them together. Number 6, again, don't forget, if you pause the video and work it out. If 2 angles of one triangle equal 2 angles of another, then the third angles are equal. So we're given 2 triangles, A, B, C, and P, Q, R. I numbered, to make it easy for you, I numbered the angles 1, 2, and 3, 4, 5, and 6. It makes it easy. So 2 angles of one triangle. So we're saying 1 is equal to 4, and 2 is equal to 5. So we're going to prove that 3 is equal to 6. So let's say that we have triangles A, B, C, and triangle P, Q, R, in which angle 1 is equal to 4, and angle 2 is equal to angle 5, and that's a given. So, as a result, that angle 1 plus angle 2 plus angle 3 is 180 degrees, and angle 4 plus angle 5 plus angle 6 is equal to 180 degrees. That's because the sum of the interior angles of a triangle equals 180 degrees. And as a result, that angle 1 plus, there's an angle there, angle 2 plus angle 3 is equal to angle 4 plus angle 5 plus angle 6. They're both equal to 180. So number 4 is that, getting ahead of myself. Number 3 is that this is a transitive property. Because they're equal to 180 here, because these three angles are equal to 180 right here, that means these three angles in this triangle are equal to three angles of the other triangle. And 1 is equal to 4, and 5 is equal to 2. That means that angle 3 is equal to angle 6 by subtraction. So notice we're subtracting 1 is equal to 4 right here. So we're taking them away. If you think about it. 2 is equal to 5. So we're subtracting 1 and 4, 2 and 5, and we get 3. 3 and that's a 6 now, see? 3 is equal to 6 subtraction. If two angles of one triangle are equal to, if two angles of one triangle are equal to two angles of another, the third angles are equal. And there's the proof. Number 7, the acute angles of a right triangle are complementary. So we're given triangle ABC is a right triangle with ACB is a right triangle with angle C a right angle. So there's a triangle, angle C is a right angle. So we're going to prove that the acute angles, if that's a right angle right here, the other two angles are acute. We're going to prove that A and B are complementary. Complementary means they add up to 90. So we're given triangle ACB is a right triangle, and we're given that angle C is the right angle. So that's the given. A right angle AB, I gotta be careful. Triangle ACB is a right triangle. Now as a result of that right triangle, what do we know? That if angle C is a right angle, that means angle C is equal to 90 degrees. Definition of a right angle. And we have a triangle, so we have that angle A plus angle B plus angle C is equal to 180 degrees. Sum of the interior angles of a triangle equal 180 degrees. And notice we now C is equal to 90, so that angle A plus angle B plus 90 degrees is equal to 180. So we took C away right here and put 90 in its place, and that's a substitution. Substitution property of equality. And notice now that if that's a 90 degree here, that angle A plus angle B, angle A plus angle B is 180 by subtraction. Why subtraction? Because we're subtracting 90 from each side. 90 from here gives you 0, 90 from 180. Oops. Again, see? Thinking okay, but not being careful. We take 90 out of this side, gone. Take 90 out of 180, 90 is left. And so that means if these two angles add up to 90, that means angle A is complementary to angle B. And that's the definition of complementary angles. Complementary angles add up to 90. Okay, one more to do. We have lots of lines. Notice this is a transversal cutting through all these lines. So we're giving all these parallel lines, and we got to prove one equal. So 1 is right here, 4 is here. We got to prove that these are equal. And we do it by, let's see, let's start with what does A parallel to B give me in relation to those angles? That's a given. So if A is parallel to B, I see that angle 1 is equal to angle 2. They're corresponding angles. So it's a PLT. Corresponding angles are equal. And now we have B is parallel to C. So we got B is parallel to C. B is parallel to C. Notice that these are alternate exterior angles. So that's a given. No, I didn't put all the givens in the first step. I'm separating them so you can see. So angle 2 is equal to angle 3, and that's PLT. And these are alternate exterior. Alternate exterior angles are equal. And number 5, we got C parallel to D, C parallel to D, and that's, again, a given. It's right here. And what do the pair of angles we get from that is 3 and 4. So angle 3 is equal to angle 4, and that's a PLT, and that's alternate interior angles equal. So I make this statement. That's what I did earlier on with the proofs. I introduced the PLT property to make sure you understood what I was doing. And so if 1 equals 2, and 2 equals 3, and 3 equals 4, that means that 1 is equal to angle 4. And that's the transitive property of equality. And I know, look at these two. If I look at these two right here, I get 1 equals 3. Then if I look at those two, I get 1 equals 3 and 3 equals 4, then 1 equals 4. So it's the transitive property at least twice. Again, check with your teacher if you're allowed to do what I'm doing here, because I put them all in one. So 1 equals 2, 2 equals 3, 3 equals 4, then 1 equals 4. Transitive property. And that's some proofs on the parallel lines. And if you like my proofs, click on the like button, the subscribe button, notification bell, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of my YouTube channel called Math Fully Explained. Notice the video is long, but proofs go that way. Thank you. Bye-bye.